Hello, GM. Welcome to the episode number 2 with Alchemy of an Upchain Labs 2 of our Account Abstraction workshop. And yeah, in the last episode, we were with Austin from Upchain Labs and also Dan and Jason from Alchemy. And we learned about what is account abstraction from zero and why builders should be interested on it. Also, we learned about how is account abstraction improving user experience and how it's going to help or is already helping to onboard the new next billion of people into the Web3 ecosystem, about the account abstraction standards like ERC 4337 and a little bit about the blobs, EAP 4844. And yeah, we also learn about what can Arbitrum provide to make account abstraction even better. And yeah, if you haven't seen the first episode, I recommend you to go and watch it. I'm going to leave the link to it in the chat, in the comments. And yeah, today is time to learn more about account abstraction with Dan from Alchemy and also Austin from Offchain Labs. They are here with us. And yeah, we're super excited for this one. How are you, Dan and Austin? Thank you for joining us today in a new workshop.
Yeah, thanks for having me again. I love the countdown music every time. It makes it feel so much more epic. And I feel like every coding session of mine, I should just start with that 30-second countdown. It's super cool.
Yeah, it's true. It's like very relaxing. How are you, Austin?
I'm doing well. Thanks for hosting and excited to learn some more about account abstraction and answer any questions that people have.
Yeah, for sure. We're super excited too. And yeah, maybe we can start with a brief introduction about yourself. Maybe Dan, can you share about you, and then Austin, and yeah, and after that we can get started with the workshop for today.
Yeah, absolutely. So I did a little introduction last time, but Anna and I were just talking about beforehand Eat Denver. So I feel like that's coming up pretty soon. Everyone's pretty excited for it. A little bit of background about myself. Actually, I really got big into the space, started joining this space and working in the space full time because of Eat Denver, the first one that they put out. We did a project back then, which became the prototype for ChainShot, which is an educational bootcamp platform that I'd worked on from 2018 until the last year when we were acquired by Alchemy. And I've been at Alchemy ever since for a year and a half, working on mostly all things Web3 education. So I'm really excited about education. That's why we're here. Super excited to get into this again.
Awesome, Dan. Thank you for sharing that. Super inspiring, to be honest. December was my first event too, and that's how I got very into the Web3 ecosystem. But yeah, super excited to have you here, Dan. And yeah, Austin, what about you?
Yeah, product team at Offchain Labs. I work across several different initiatives, including Stylus and Orbit and some core protocol upgrades. And that really includes our future of account abstraction on Arbitrum, which we feel very strongly about, and whether that be supporting the ecosystem of account abstraction projects or even like going as far as upgrading the chain to better support account abstraction. There's a lot that we can do on that end.
Amazing. Exciting to have you for sure. You're going to give us very, very cool comments about and knowledge about account abstraction. Nice. So yeah, you'd like to share a screen then?
Yeah, absolutely. Let me go ahead and do that. So today, have a presentation for everyone to kind of go through a little bit more of the technicals about what we talked about last time, because you're probably really excited about account abstraction from last episode. So now we want to talk about actually the practicals of how it's working and get you a little bit more ready before we dive into talking about the use cases in the next episode, and then following up with some workshops in episodes 4 and 5. So let me go ahead and share screen, and then we can hop right on into it. All right. So we are on account abstraction, episode 2. We're going to be learning about ERC 4337 and ERC 6900. Don't worry, I'll define both of these standards because there's always a lot of numbers, especially in account abstraction. I feel like there's so many numbers and it's hard to keep track of them all, but we're going to be talking about these standards and why they're important. So thanks for being back here again with Off-Chain Labs and Alchemy. We're excited to be here. Great. So last episode, we talked about this idea. I really like to say that account abstraction is flexibility at the account layer. And the reason why I like to say that is because it's hard to define exactly what account abstraction unlocks because it is a lot of features all packaged under one term. So I like to say that it's flexibility at the account layer. It unlocks a whole realm of new Web3 user experience. So this GIF here, I took from a video that you can find on the Alchemy YouTube where we talk about account abstraction and we take a look at some different experiences that you could have in an application and how we can unlock Web 2 like experience in a Web 3 app. So that's what you're seeing here in this GIF, where you have a user who's signed in, maybe authenticated through OAuth or maybe authenticated through email password, something like that. And they come in here and they just click a button, and that button behind the scenes is actually sending a transaction into the blockchain. And you can see on the Arbitrum here that the transaction is actually happening behind the scenes. So that's the kind of experiences that we can unlock with account abstraction, but that's not the only experience, right? And I'm here to talk about all the different experiences we can unlock for all the different use cases that you might need those experiences for. So let's take a step back first here and just talk about the state of the nation here for Ethereum virtual machines. So when we talk about Ethereum virtual machine networks, when we talk about controlling an account on an EVM chain, there's two ways to control an account. You can control an account using an externally owned account. And what this means is you have a private key that controls an address on chain. So your private key is the authentication for that chain. This is actually something that's built into the protocol. So protocol nodes will recover from your signature your public key, which then translates to your address. And they say, okay, this signature, this person who signed this, has the authentication to go ahead and run transactions on behalf of this address. So that's one way to control an account. The externally owned account, the big advantage that it has out of the two ways to control an account is it can initiate transactions. This is opposed to the other way you can control an account, which is a smart contract. And a smart contract is a blockchain program, something that you could take some code and put it on chain, typically in Solidity in EVM ecosystems. But that's not the only smart contract language. With a smart contract, you have full programmability, so you can do whatever you can possibly fit within a block inside of a smart contract, right? So you can program whatever you can possibly imagine. The problem with a smart contract is it cannot initiate transactions. So account abstraction, what we really want to do is we want to get both of these things. And I'll talk about why we want to get both of these things, but we sort of want to put them together. We want to merge them. We want to abstract several of these problems that we have here by introducing these two different accounts. So we want to be able to get full programmability with the ability to initiate transactions, both the EOA and the smart contract, the advantages of both, the disadvantages of neither. So one thing that you could be doing today, and many people do this, which is manage a smart account with or a smart contract with an externally owned account. So you may already say to yourself, Dan, why are you telling me I can use a smart contract like an account? I already do that today. I have a multi-sig that I have on chain and I'm controlling it with an EOA, and that is my account for all sakes, for all intents and purposes. And that's very well, but there's a couple downsides to using that this way, which is one, when you have a smart contract on chain that you're using kind of like your account, you have to have a EOA that maps to, like I was saying, you have a private key that maps to an address on chain. That EOA is going to have to hold its own gas money. It's going to have to hold funds that it's going to pay for gas for transactions. And then you also have some funds in your account. So now as a user, this is the most important thing, right? We're talking about onboarding the next millions and billions of users, the mainstream users that are coming to Web3. For those users, like, do we really want to have user experiences where they have to manage funds in two different accounts and you have to teach them, oh yeah, this is the one that you sign with and this is the one that actually holds the assets that you care about. You have to keep gas money in this one. You have to keep your assets that you care about in this one. It's kind of an annoying experience, right? The other thing is just the idea that you have to consider two addresses, right? So your EOA is mapped to an address on chain from the private key, and then your account also has an address. So in the instance that you have a user who has a smart contract that they're managing with an EOA, you kind of have to teach them about both of these things, right? Keep your private key safe, put gas funds inside there so that you could be able to interact with your contract. You have to teach them both sides of these things: good management for your smart contract, good management for your EOA. It really complicates the story if we want to be able to get that full programmability that we would want for an account. And I'll talk about why we want that full programmability in a second as well. So with one smart account, what we want to be able to get to is we want to get to this point where we have a smart contract on chain where we can control it by a key or maybe multiple keys. So it's kind of like taking the private key and putting it inside of the smart contract, putting them together as one. Now we're going to see with ERC 4337 or even with native account abstraction, it's not as simple as this, right? But this is what you can think of as a user. You could present this to your users as you have an account that's controlled by key or keys. And that's the important thing here. We want to get to this point where we kind of abstract all of these other things away. And we say to the user, here's your account. You could control it with a passkey on your phone, or maybe a hardware wallet, or maybe it's a session key that's inside of the browser. You want to be able to give your user this ability to be able to do things like that. We'll talk about some of the user experiences you could build with this. So in this case, these keys that are inside of the smart contract, they sign the intention, which is to say, I am signing what I want to do with this account. They're not signing the transaction. They're not treated like an EOA. So the keys in this case don't have a separate address calculated by the protocol nodes, and they don't need to store their own gas funds. They are just used for authentication of the smart account. So one thing I want to talk about now is, I mentioned this a little bit earlier, but this idea that the smart account has some advantages versus an EOA. Like, you may be thinking, Dan, why don't we just use externally owned accounts? I've been using externally owned accounts for years. They've worked great for me. Why don't we just stick with this, right? Why do we need full programmability for our accounts for our users? And there's a couple different reasons. I'm not going to be able to enumerate them all, but I want to give you like a good understanding of some of the things that you can do. There's one thing that you could do, which is integration with contracts. This is a big realm of things that you could potentially do that you can't do with an EOA. And because smart contracts are fully programmable, really this is an infinite idea. But with smart contract accounts that are on chain, you can integrate with other smart contracts. So the most basic example of something that we can think of that exists today is like NFTs. So NFTs, they have this, most of the NFTs today have this method baked into them where they detect if there's an address out there that's a smart contract, and they ask if it's safe to transfer over to that smart contract. And if it's not safe, then it won't send, it'll revert in that case. This is really important because you can imagine how annoying it would be if you accidentally sent your NFT over to an account or over to a smart contract that doesn't know how to interact with NFTs and is not upgradable. There's a possibility there that you send an NFT to a smart contract that can never interact with that NFT, and therefore that NFT is now bricked. You can't use that NFT ever. Your Bored Ape becomes a burned ape. I thought of that one beforehand. I thought that was pretty funny. That would be pretty rough, right? You want to be able to integrate with contracts, things like the ability to say to an NFT, yes, it's okay to say transfer over to me. Something else that you could do that we're going to be talking about, especially later on in the workshops, is having custom validation rules. So something really cool on Arbitrum that you can do is you can use Stylus to be able to use Rust with your smart contracts and be able to get the efficiency gains that you would get from using the Rust language. So a good example of this is being able to use the SCCP 256R1 signature as opposed to the typical K1 signature that's used today. So when you use an EOA, when you're managing it with like MetaMask or your mobile wallet or hardware wallet, you're signing a signature that gets sent on chain that's recovering that public key. That's all using K1 curve. But we also want to be able to use the R1 curve, which is used for passkeys. So if you've used a passkey before, you may be familiar with it from doing things like using biometrics, so maybe your fingerprint or your face, and then it gives you access to a key that is going to sign something with this R1 curve. We can go ahead and create that custom validation rules inside of a smart contract, be able to fully program that and be able to say like, okay, R1 is an acceptable curve to be able to use this to validate it, right? So we kind of move the signature validation from a protocol rule to a smart contract rule, at least when we're talking about 4337, which we will be in this episode. So the last thing that I want to mention here is the ability to change the security model. If you've been in the space for a while, this is probably something that's annoying to you as well. I know I have a bunch of old EOAs that have like state acquired to them, right? They've interacted with certain things. They have soul-bound tokens that will never be able to change their security model, not unless certain EIPs are adopted in the future. But unless that happens, these EOAs are unable to change the security model, meaning the only way that you can keep that EOA secure is by hiding that private key away, doing something to make sure that nobody ever gets access to your private key. This is something I would want to be able to do, is be able to take some of those EOAs and be able to change the security model. So maybe if I have an account that I really care about, I want to be able to manage it with 2 keys or 3 keys, or have social recovery, something like that, right? I want to be able to change that security model, especially as the account becomes more and more important to me, which it has for some of my old EOAs. That I've been using to interact with the ecosystem for many years now. So there's been many account abstraction proposals. It's a tough thing to do account abstraction and talk about it generally because there's so many different proposals here. But I do want to cover some of these very, very basically. So EIP 86, it's interesting to toss this one in here because this one was proposed in like 2016 or 2017 when the only person who was thinking about account abstraction was Vitalik. So Vitalik put this out there. There may have been other authors on here as well. I say that somewhat facetiously, but there wasn't as much thought about account abstraction around that time. I mean, this really makes sense. We talked about this in the last episode, why some of the use cases that emerge don't really care about account abstraction as much. But as we move towards more mainstream use cases, we really care about these new user experiences. So EIP 2938 came out to talk about how we could get account abstraction natively on a chain. But this will require protocol changes as well as 3074. 3074 gets lumped in here quite often, although I've seen some folks talk about how this could be used with account abstraction, could be used with ERC 4337. So I just wanted to point it out there. It's basically like this ability to be able to give delegate responsibilities to an EOA. So it kind of has like these account abstraction like properties, although it's like a very different idea. ERC 4337 is the one that we're going to be talking about today. And the reason why we're going to be talking about it today, and the reason why it's gained so much adoption, is because it's account abstraction without protocol changes. So we can go ahead and start working with ERC 4337 today. In fact, we have, right? There's quite a bit of adoption, as we'll show a little bit later when we take a look at a Dune Analytics dashboard to see how many accounts have been made across all the different chains and how many user operations have been sent today. Of course, it's still all very small today, right? But you can see that it's moving in a direction where we are definitely seeing more smart accounts made every day and more user operations. And I think this will continue to grow and grow and grow. Finally, the last thing I did want to mention here was RIP 7560. So this is native account abstraction, just like 2938, but it's also compatible to 4337. The other thing that's interesting about RIP here is that it's a roll-up improvement proposal, right? So the idea here is that we could get something that is compatible with 4337 that roll-ups can potentially come and implement. So then you could use these smart accounts natively within the ecosystem. You don't have to introduce some of the smart contracts that I'm going to be talking about in a moment that would be needed if you were going to use ERC 4337.
Sweet. Yeah, I think it's the proposal landscape is pretty interesting in the trade-off space between them. The one point that always kind of helps me understand the difference between them is like 2938. You can almost think of like allowing smart contracts to function more similar to EOAs, and then EIP 3074 you can think of as allowing existing EOA wallets to function more like smart contract accounts. So they're almost like the functionality is almost swapped. It's just, optimizing who can act like who. And so it's definitely quite interesting.
That's a really great way of putting that. Yeah, thank you for chiming in there and saying that. That's a perfect way of putting it. Yeah, and really sums it up there. Sweet. Okay, cool. So we'll go ahead and jump into ERC 4337. So ERC 4337, like I mentioned, is account abstraction without protocol changes. I only actually learned recently that ERC is for standards that are not changing the core protocol versus EIPs. I feel like people get that mixed up all the time. I don't know when we started making that differentiation, right? But it's a good one to make. So you'll even notice in the last slide, right? We have EIPs and ERCs. The IPs are referring to things that are going to change the actual protocol. The RCs are going to change a standard. So there's something that you could adopt if you're interacting with the protocol, if you're a smart contract or you're a library that interacts uh, um, with the protocol. So ERC 4337 is actually going to outline something that all happens outside of the protocol. Does not require protocol changes, but it requires all of these actors here, which are all labeled in these icons. So that's what I'm going to be talking about here. So ERC 4337 is a pretty complex system, I would say, but it's not so bad if you can take a look at it on a high level and just say that there's 5 roles of ERC 4337, especially coming from someone who's more familiar with smart contracts and keys. If you just break it up like this, it becomes a little bit easier to look at. So you have a user and a bundler that are both going to have keys. And then you have 3 smart contracts, which is the entry point, the paymaster, and the smart contract account. This is how I like to break up 4337. Makes it a little easier to think about. So the user at the end of the day is still going to have a key. This is important, right? But that key is not going to sign the transaction. The key that's going to sign the transaction is the bundler. So what that does is the bundler is now acting as the EOA, so the user doesn't have to, right? We'll see this in a moment, but we're going to get rid of those disadvantages of the EOA by allowing the user to have a key that no longer has to take those responsibilities. So state changes without account abstraction kind of looks like this today, where you just have an externally owned account and you submit a transaction. Behind the scenes, the protocol is going to recover from your signature the address that that externally owned account private key controls on chain, and then you make state changes, right? You talk to a smart contract, that smart contract talks to another smart contract down the line, right? That's what we really want to do at the end of the day on the EVM. We want to make state changes. Anything that you do in the ecosystem is making state changes, right? That's what we care about. Transferring NFTs, interacting with a DeFi protocol, making a post, right? Like anything in the Web3 ecosystem that's on chain is something that we would be trying to make state changes on the EVM. So how do we move our account on chain? This is what I talked about earlier, right? We want to get that full programmability of an account that we can do things like interact with the ecosystem or be able to get our own type of cryptography built in, all that sort of stuff. We want to get that full programmability on chain. So we introduce something like a smart contract account. Now, of course, within this image here, we have that problem of controlling 2 accounts where we have to keep funds in the externally owned account and we have to keep track of the addresses of the EOA plus the smart contract account. So now we have that problem. 2 addresses, EOA has to pay for gas. So how do we get rid of that problem? How do we avoid being the EOA? This is where we introduce the second key, which is going to be the bundler. I'll talk about why it's called the bundler in a little bit. In this image right here, it looks more like something you might call a relayer, where you actually like relay a transaction on chain. You relay an intent on chain, right? You have the user who's over here signing something that's like a meta transaction, and that transaction gets wrapped up inside of an actual transaction that then gets sent on chain and then obeys the protocol rules, interacting with a smart account, and then making those state changes. All of that happens within the EVM. So now we have a bundler. But the bundler has a bit of a problem, right? We want to make it in 4337 so we can have many, many bundlers. We can have people running bundlers. The bundlers have a specific a set of code that they have to adhere to, specific set of protocols that they have to adhere to, so we can have a mempool of user operations, kind of like a node in the Ethereum network. But in this instance, in this image that we have right here, the bundler has to pay for the gas, right? Because somebody has to pay for that gas, and the bundler is the one who's acting like the EOA. They're the one who's signing the transaction that contains the user intent that then is being translated on chain. So they're paying for the gas. That doesn't really make sense, right? Like, it's going to be hard to figure out a way to make sure that the bundler gets paid back at the end of the day, because all of that's happening off chain. If that were happening on chain, then maybe we could make sure that the bundler was getting paid back. And that's sort of what we want to introduce here, is a way to put something on chain to make sure that we get pay back the bundler at the end of the day. So how do we charge gas? Not to the bundler, because we don't want the bundler to be paying for the gas at the end of the day, but the account. And this is where we introduce another smart contract, which is called the entry point. The entry point has this job to do, which is to see every operation that comes in. I'm now using this term operation, which I'll define a little bit later, but the operation is what the user is going to sign all the way on the left over here. They're going to sign an operation, and then that operation is going to be sent into the entry point through a transaction from the bundler. The entry point is going to see how much gas that operation is going to cost, and it's going to charge it to the smart contract account, right? In this image right here. So the entry point is going to be doing that calculation. It's going to facilitate the interaction between the bundler and the smart contract account and make sure that the bundler is paid back for at the end of the day. But what if we want to have somebody else who wants to pay for gas, right? Like, we don't want to have the entry point pay for the gas, or sorry, we don't want to have the smart contract account pay for the gas in some cases, right? You might have a use case kind of like the GIF I showed in the very beginning, where you just want to have a user be able to click a button and be able to do something on a blockchain, kind of like an open database, right? With some rules baked into it. If you want to have this kind of user experience, which makes sense for certain use cases, right? We could introduce a paymaster, somebody who is going to pay for the gas on behalf of the smart contract account, maybe under certain conditions. Maybe there's a promotion that they're running, maybe they're only doing it for onboarding, or maybe they're willing to do it for this smart contract account forever, right? We could talk about some of those different user experiences and why a paymaster may want to do this for its users in a moment. So here we have the full ERC 4337. I don't have any more actors to add to this image, so no more question marks. This is it, right? This is what you saw a moment ago. We got 3 smart contracts on chain, which are entry point, paymaster, and smart contract account. And now we have 2 keys. The bundler is acting as the EOA. It has its own address that's going to sign transactions to put it on chain. But because of the interesting dynamics of ERC 4337, it is not burdened with paying for the gas. Technically, it is burdened with paying for the gas, but the entry point rules dictate that the bundler will get paid back based upon the code that's inside of its smart contract. So this is ERC 4337. Somehow, amazingly, a smart contract system has been able to abstract away this idea of paying for gas from an EOA, which I think is just extremely clever and cool that this was built. So the 5 rules.
Oh, sorry, Dan. Yeah, there is a question that I think is very, if we can answer it now, as it's related to this topic.
Yep.
Is how are the bundlers incentivized? And also, Big Changer is asking, does bundler take a fee?
Yeah, so typically bundlers do take a fee. So that is, their incentivization. That is the pretty much the answer there, right? So in this case, like, the bundlers do need to, like, there is like an operational cost that they need to provide. And certainly there's a lot of work that needs to be done to build these bundlers. And so, bundlers typically take a fee, and that is done through the fees that come in from the user operation. There's also like something that's built into the entry point, which is the fee recipient at the end. So when you send operations through to a entry point, typically the bundlers will specify themselves as the fee recipients.
Yeah, and I'll also add there that there is a level of risk for these bundlers because they really only get paid back. They only get reimbursed for those gas costs if the transaction is actually able to execute. And so if the transaction reverts, then they are still on the hook for the gas fees, but they never got reimbursed. And so this is a level of risk that the bundlers have to take on. And so making sure that you have very good validation and simulation in place for those user operations before they actually get submitted on chain and executed is super important for giving bundlers the confidence that they will get reimbursed and that those operations that they are bundling and putting on chain will actually execute successfully.
Yeah, thank you, Austin.
Nice.
Anna, was there any other questions for there?
Well, there is another question that it says, is there any way to migrate or link an EOA to ERC 4337 wallet?
to link them to ERC-4337 wallets. So the interesting thing in the case of 4337, so I wonder if this question is asking like if you can kind of link them together to kind of use both. I mean, in the context of 4337, you can have your EOA. So like if you're thinking of something like MetaMask and you have a key inside of MetaMask, that key, what it could do is it could sign an operation, which is the intent of the user, which is then run against a smart contract account. So you can have your EOA act as the key to authenticate actions for a smart contract account to control that smart contract account. As far as like linking them together, like if you wanted to be able to use both, I think that, there's certainly flexibility there to be able to do that. But the idea here is hopefully to move most things over to smart contract accounts for these benefits here. So in that case, like the EOA would be treated more like a key that's signing something that's validated by the account versus something that's actually holding on to assets and has an address on chain, if that makes sense.
Yeah, you can't migrate an EOA to a smart contract unless there is a change at the protocol level that outlines a path for that, which does not exist on Ethereum or any like EVM equivalent L2s today.
Yeah, which I would fully support because, like I said, those EOAs. If you have an EOA that you've been using for a while and it's valuable to you, you probably want to move it. You don't want to just move all the assets over. In some cases, you can if they're soul bound. Right. Cool. Yeah. So.
Fantastic. Thank you. You can go ahead now.
Thanks, Anna. Cool. So the 5 roles of your C4337, just to sum them up, you got the user and the account. They kind of work together, right? So you got a check mark up here in 1, and you got a check mark here down in 5. The user is authenticating, the account is validating. So that signature basically gets relayed over to the account eventually to validate that that user can indeed run transactions, run operations against that account, right? So the user and the account kind of work together, right? Just as I was talking about a moment ago, you could have a MetaMask key, private key in MetaMask or in a mobile wallet or in a hardware wallet that is signing something that is validated by the account, and they kind of go hand in hand. Then you have the bundler who's really offloading that responsibility of acting as an EOA from the user. So now you have somebody who is, like Austin was saying, who's taking on the risk of sending a transaction on chain. We'll talk about how bundlers mitigate this risk in a moment as well. They are taking on that risk of like sending something on chain and not getting paid back, right? But hopefully everything here that we're talking about is airtight enough where the bundlers are not at risk of not getting paid back, right? That's the importance of building a strong and secure standard here. So the bundler is going to sign and submit the transaction, kind of like how the EOA would previously. But then the entry point is put here to make sure that the bundler gets paid back, right? So if everything is good and set there, then the bundler is going to get paid back at the end of the day by either the account or the paymaster. Either one can do it. The paymaster may have certain conditions under which it's willing to pay for the user operation, and in other cases, the account will pay for the operation. And finally, the account is going to execute the transaction, right? This is where we really want to get up to, is the point that the account is making state changes. Really, at the end of the day, from a user's perspective, it starts really where step 5 ends here, which is going and making state changes. So this is kind of where we want to like think about. We want to get to this point where we could see this image and really understand everything that's going on here. So I've kind of already talked about this idea of an operation. I want to get down to the level where we feel comfortable with this image a little bit more. So we're going to be talking about it a little bit more technically. So I'm going to come back and build our way back up to this image in just a moment. First, I just want to talk about the first piece here of that image, which is the user and the bundler. So we talked about this idea that the bundler is offloading the responsibility of being the EOA from the user. So the user, what it's going to do is it's going to sign a user operation, right? So now I'm actually defining this term. The user operation has a bunch of fields. Here's some fields here: sender data, paymaster info, nonce, init code, and gas params. Some of these probably seem very similar to transaction parameters if you've dealt with a transaction at a low level, right? But some of these are new. They're different from a transaction. They have to specify a paymaster info. They have to specify the sender, which is going to be the smart contract account that is actually going to execute this, right? So the AA user is saying, this is a smart contract account. that is actually going to execute this user operation. Now, of course, the smart contract account on the other end is going to validate that indeed that AA user can actually sign these user operations on their behalf. That's where the validation comes in, right? And that data right there is kind of like the call data, how we typically think of it when you have an EOA that's just signing a call data to interact with a smart contract on chain. But this data is going to be the data that starts at the account and moves forward, right? So it's really the call data that we used to think of. So if you are trying to interact with Uniswap, right, and you want to just approve some tokens before you transfer them, that approval is going to be encoded in the call data here inside of the user operation and eventually sent from the account to the Uniswap contracts. Paymaster info is going to give enough information for the paymaster to know that indeed this is something that it's willing to pay for. Typically, the paymaster is two parts. Somebody who's running a paymaster will have a paymaster server, which is going to sign things and say, yes, I'm willing to pay for this user operation. And it's going to check those conditions off chain. And then it's going to sign something that the paymaster smart contract on chain is going to say, oh, I know that that comes from the account that's allowed to authenticate paymaster user operations. So then the paymaster smart contract on chain will also then go ahead and send this through. Then you also see the nonce, the init code. Nonce is very similar to transaction nonce, but it's managed by the entry point itself on chain. The init code is going to be when we are actually initializing a smart contract for the first time. So that's going to be sent in there as well. If you're not initializing it, you wouldn't send it in. You just send in 0x for a init code, but that first time that you create a smart contract, you want to send that through. And then finally, some gas parameters. There's more gas parameters here than a typical transaction, but we don't have to go into them right now. That's definitely something we'll talk about in the workshops. So the reason why we call it a bundler and not a relayer, as I mentioned before, this is not a new schema, right? This is not a new idea. This idea of like having a transaction that is relayed on chain. And in fact, typically it's referred to as relayers, where you would have nodes that are operating doing this responsibility. But with ERC 4337, this is the first time that we've really standardized it and tried to create something where we could have like an open mempool of user operations that are actually getting relayed on chain. In this case, we're calling it a bundler because it takes many user operations and we'll put them together in a bundle inside of a transaction and then put those transactions into put that user ops into a transaction that's sent to the entry point to handle those user operations one at a time. So many users are going to send many user operations to a bundler, just like today how many users are using EOAs to send transactions to a node on chain. So you can kind of think of a bundler as the node of account abstraction. So the job of the bundler is to collect many user operations, to verify those user operations, as Austin mentioned, to sign them in a transaction and send them off as, to an entry point. You'll notice that I put Alchemy's logo here inside of the bundler. Alchemy has its own bundler that's open source called the Rundler. It's written in Rust, so you can find it up on GitHub if you're curious about how that works. And so, yeah, we have the bundler there. This is the job of the bundler. The bundler has to simulate transactions first. And this is kind of what Austin was alluding to earlier, which has this responsibility of making sure that user operations are actually valid first, right? Because you don't want to put a user operation on chain that is not going to pay the bundler back. Because think about this, right? The bundler is, if we know, okay, so first let me just tell you, in case you don't know, when you sign a transaction, you put it on chain and that transaction fails, it reverts, you still have to pay for gas, right? Because if you're a user that has an EOA and you're signing a transaction on chain and you're forcing all the nodes in the ecosystem to revert, to run that transaction and to revert and have that state change be on the blockchain forever, you are taking up resources of the ecosystem, right? So even in the case of a revert, somebody's got to pay for the gas. The bundler does not want to pay for the gas in that instance, right? So what the bundler does, and one of the big things that the bundler is responsible for, is simulating every user operation and making sure that that user operation is actually going to pay back the bundler, right? It's going to make sure that the paymaster is willing to pay for the user operation if that's encoded in the user operation. It's going to make sure that the smart account can actually run that execution and pay back the gas if the account is going to pay back the gas, right? So the bundler might get many, many user operations, and it may only take some of those and put them on chain depending on whether they are valid or not, right? So that's a really important job of the bundler here. So Executing user operations is going to look like this. And finally, we're getting back to the original image here, right, where we have the user operations. The first question that came in from the chat was whether the bundler gets back some of the fee recipients. This beneficiary here that is specified to the entry point is actually the fee recipient. In the entry point here. So that is where that could be specified. The user operations is going to be a bunch of operations that can be sent on chain. And then the entry point, what it's going to do is, if we take a look at this image right here, right, the dotted line shows that this is all happening within the EVM. We have the entry point, and the entry point for every user operation is going to go to the account to verify that that user operation is first valid. Can this user actually execute against this account? Then it's going to ask the paymaster if the paymaster is included. Paymaster is going to say, yes, I'm willing to pay for that user operation. Then it's going to call out to the account. That's where we're going to get the actual state changes, right? That gray box is what we typically think of as just transacting with the ecosystem. That's what we really want to get to. We have this big whole system that we're setting up here just so we can get that gray box, right? That gray box is what we care about. That's the account interacting with Uniswap, or that's the account buying a Bored Ape, or that's the account, I don't know, whatever you could imagine happening in the Web3 ecosystem, right? And finally, we have some post operations as well. So there's quite a few things that the entry point is facilitating and making sure that at the end of the day, the bundler is not paying for the gas. Somebody else needs to be doing that for the account. So before we take a couple questions, I do have a break in here for some questions. I want to just take a look at some user operations in real life here is what I labeled it. So there's a really great explorer from Blocktorch, and I will make these links available. Maybe we could drop them in the chat. Maybe we could, I'll try to put the presentation in the chat in a moment. But Blocktorch has this great explorer. You could type this in, or I'm sure you could just search it on Google and check it out, where you can take a look at some of the user operations that have occurred and actually see them visualized, which is super cool. So I did want to take a look at this. When you pull up this page here, it actually will come up with some transactions below. Typically. Oh, there we go. Sweet. So these transactions are actually pre-populated. You can see most of them happened 2 months ago, but some of them are from a few minutes ago, right? And you can see a whole bunch of different transactions that have occurred. We can see one on Arbitrum right over here. So if we take a look at this one, we can actually see a user operation occurring on an Arbitrum chain. And we can actually see what happened here. So this is the visualization here. If you look up at top, it says the user intent, and it actually says,
hey, Dan, I think you need to maybe switch tabs, or you're still on the slideshow.
Oh, thank you. Thank you. Shoot. Okay. Let's see. Sorry. I should have seen that coming. Let's stop sharing and then share my screen, the whole window. Let's do that. There we go. Cool. Okay, sweet. So yeah, here we go. Thank you for saying that, Austin. So Blocktorch, what I pulled up first is this page right here, and then you can see many transactions. And in these transactions, we can click on one, and then we can jump in here and actually see the user op. So this is the user op right here. We could zoom out a little bit here, but I don't want to zoom out too much. You can see the user operation. It's going into a mempool, and then this one is getting picked up by the Biconomy bundler, and then that Biconomy bundler is interacting with the entry point. This is going to call the handle ops method on the entry point, which is then going to, for every user operation, it's going to run through and make sure that it's valid, right? And then it's going to actually execute it. You can see that the Biconomy paymaster is actually included in this case. And then there's a smart account at the end of the day that's trying to do something here, right? So you can click on these things and actually see what's happening in here. There's a validate user operation. So you can see at the top level here, there's a handle ops call. I don't know if you guys can see my cursor, but there's a handle ops call up at the top. Maybe if I close out right there, you can see that there. And then underneath that, we have a validate user op, which is actually calling out to the smart account first. And then it's calling out to the paymaster to say, hey, is this a valid user operation you're willing to pay for? And then it's calling out to the entry point 0.6.0. There are different versions of the entry point. 0.6.0 is the most popular one right now. 0.7 is on its way. 0.6.0, you can see there's this inner handle operation that's actually occurring here. We're eventually going to get down to the point of where we are actually doing the thing that we tried to do, which looks like an approval and a swap token, right? So this is what is actually trying to occur right here, which is a smart account is trying to approve and swap a token. So you can actually see that here. the whole user operation, how it's visualized, and then you can also see what's actually happening in here as we're interacting with the ecosystem to approve and swap some tokens. So this is a really cool visualization. I also know that there are some visualizations. I wonder if I zoom out, I could probably find them. I know there are some that failed. Oh, this looks like one that failed maybe. That's kind of helpful to see. I know as we go into the workshops later, it's going to be really helpful to know some of these error messages and be able to see what actually happens on chain when you try to execute a user operation. Because especially for account abstraction with ERC 4337, there's a lot of things going on here. So knowing where it failed in the pipeline is really, really important. So visualizations like this can really help, and especially getting really important the custom error messages, like this case, AA95 out of gas. That's probably coming from the entry point, which usually labels the errors with AA something, saying what exactly happened here. So there's an out of gas. There was also another one I know in here, although I don't see it at the moment, which is one that actually fails when trying to interact with the smart contracts. So like you'll notice in this case, like what's actually failing here, the execution is reverting in the system of ERC 4337. So this is an issue with the system itself setting up the user operation. But sometimes it's important to know whether it's like, is it failing because the user operation is trying to do something with the ecosystem that's failing, or is it failing because something that's happening within the system of the user operation itself within 4337 is failing? In this case, it's a 4337 case, but in other cases, it might be interacting with the ecosystem. So this is a really cool visualizer to be able to see some of that stuff. We'll definitely be checking this out later. One of the cool things you can do with BlockTorch is you can actually run this against a local node. So you can see if you have a user operation that fails, you can see that information to be able to know what actually is happening there as well. So we'll be coming back to this tool a little bit later on in the episodes. Another thing here to check out is Dune Analytics puts out this account abstraction table where you can come in here and you can actually see all the things that's happening in account abstraction. I mean, this is really exciting. I don't know for most of the audience how long you guys have been in the ecosystem, but this kind of reminds me of looking at the early days of decentralized exchanges on chain. And Dune Analytics used to have like a dashboard back then where you could see like all of the different or how many transactions were actually going through decentralized exchanges. And it was really, really small back then, right? And I used to look at this dashboard back before we really had like a lot of transactions going on chain and being like, well, it is growing, right? That's what this kind of feels like right now is like user operations are growing. It's still really, really small. So Austin talked about last time, like in one day, I believe ZTX put 200,000 smart contracts, smart accounts out there on Arbitrum. And I think that might even be like right here, right? There is like that big bump right there. So even like one company at this point putting out there like to a big audience and saying, hey, you can do something on chain can be a big bump in this analytics right now. So this is still very, very small, but we're definitely seeing some growth here. We're seeing some more accounts being put on chain. We're seeing a lot of things occurring here. So this is really exciting to keep track of and know what's exactly happening in this ecosystem, but it's still very early days, right? If you have a drop to 100,000 users that are interacting with a smart contract account, we'll see it show up on this dashboard here and I'll celebrate you. So super cool. Yeah, so that is everything on ERC 4337. I wonder, Austin, is there anything that you want to add before we take some questions here?
I mean, I think you covered the whole kind of user op transaction lifecycle pretty thoroughly. I think like, topics that we can definitely cover in future talks is like, all right, so now we know how it works. What can we actually like enable with that? It is, two sides of the coin. But yeah, happy to take any questions if there are any. I know we answered a few earlier, but yeah.
Yeah, there is one question, but before we answer that question, Dan, can you share with me the links?
Yeah, absolutely. So I wonder if I could
Yeah.
just share this presentation.
Thank you.
So if anyone wants to go into the presentation, you could probably just grab the links from there.
Awesome. Yeah, thank you. That would be super cool. So yeah, now it's time. as mentioned, you already answered some of them during the talk, but there is another one here from Auf. Is there any way to migrate or no? That one is not. Wait. Yeah, you find it. Can an ERC 4337 wallet act as the key to sign a transaction to send assets from a EOA?
So yeah, so I'd be curious about why, if I understand the question correctly. It sounded like the question was, can a smart contract act as the key to a transaction, kind of like an EOA? I mean, the answer is it sort of does, right? But smart contracts, they don't have a key. So anything you have in a smart contract today, at least without like, super zero knowledge stuff going on, is all public, right? So you can't just like put a key in a smart contract and let it sign stuff. That's all state that we can all see on chain. But it does act like an EOA because it sends call data to a smart contract. And that's really what you're trying to do from an EOA. So in that sense, it's basically an EOA. It is replacing an EOA, but it's not doing it in a way where it's like signing a transaction and like having that transaction validated by something.
Yeah, the use case is a bit backwards, but like if we're just talking theoretically, like an ERC 4337 wallet is in essence just a smart contract. And if you want to go in your EOA and give token approvals to that smart contract, and then the smart contract now has permission to transfer tokens out of it, then I believe it's technically possible. But yeah, the ordering is a bit backwards. So yeah.
Yeah, that's a good way of putting it.
Awesome.
Cool.
Thank you for your question, and yeah, thank you for answering it. And there is another question from Hurricane. What are the potential security issues with account abstraction?
Hey, that's actually a great segue into the rest of the presentation. So we are going to be talking about ERC 6900. I mean, I think Austin alluded to one of the security concerns that you might have from like a system perspective, right? Which is that like we definitely have to build an airtight system, and we, this is being done openly by folks at the Ethereum Foundation, as well as all the contributors throughout the ecosystem, helping to build bundlers and helping to work on the entry point and all these standards and everything, right? This system that we're looking at right here has to be airtight. Otherwise, you could have the bundler that's, potentially not getting paid back for some of its transactions. Something that's interesting to think about, though, is like from a user perspective, you don't have to be worried in terms of something being signed that is not your intent, right? What I mean by that is like if there's an issue with this system, yeah, the bundler might not get paid back, but if you sign something, it's not like somebody can like change what you signed and make it so that you sign something else, right? So there's no like issue of it like potentially like malforming your transaction or anything like that. So like it doesn't add any additional security risk in that regard versus an EOA and what you sign there, right? Potentially you could sign something with an EOA that you didn't mean to sign, and that's where we need to show good data to a user to show them what they are signing. That still applies to account abstraction. So that's an important thing to know for the user. There's some risk in this system as it is, but that's really kind of like offloaded, not to the user, but to the bundler who needs to get paid back in this system. But we'll talk about like when it comes to smart accounts, this is a whole nother side of the conversation. When it comes to smart accounts themselves and the security that we have to think about when we are installing functionality on smart accounts, that's a whole nother conversation, right? Because now you're depending on your smart contract to have programmability inside of it. And you want to make sure that that programmability is what you want it to do and also that it's secure. And we could talk about like how smart contracts or smart accounts can evolve, how smart accounts work today, that sort of thing as well.
Yeah, I can touch on this point too, which is that like right now, if you're using a smart contract wallet, you're essentially relying on the bundler to actually submit the transaction on chain for you. And so what that means is that like the bundler wants to censor you, they can. In the future, there's going to be a public 4337 mempool where any like bundler who is part of this process can then, they're almost competing to bundle your transaction. And so like even if one bundler wants to censor you, another one will come in and execute your transactions. But like right now, 4.3.7 is still early, and we're really still figuring out the way to enable that kind of public mempool, which has like other security considerations like DDoS vectors, and really any type of permissionless system has its trade-offs. But as of right now, you are kind of relying on that bundler to not censor you. However, you can switch to a different bundler, but there is always that risk.
Yeah, that's a really great one that I didn't touch on. Thanks for pointing that out. And you can see on the block torch, if you go over here, that depending on which one you'll click, you'll see all different bundlers in here. So I know I saw some Pimlico, some Bioconomy, some Alchemy. So you'll see a bunch in here as they load in there, and you can see them. And soon enough, they'll be sharing the user operations, much like nodes do today with transactions.
Awesome. Thank you. Thank you for answering that one. And yeah, the last question is from Pete as well. What are your thoughts on ERC 6951 for account abstraction in gaming?
Wait, which one? Can you say the number again? Sorry.
Oh, yes. Here, ERC 6551 for account abstraction in gaming.
Ooh, good question. I don't know. I don't know that one. Unfortunately,
I can jump in on this one, in that like, so here for the crowd, like ERC 6551 refers to token bound accounts, which essentially allows NFTs to act as a wallet themselves. And so like you can have an NFT that holds other tokens and other NFTs. It's certainly a standard that's exciting, but relatively independent from account abstraction. There's definitely ways that they can, interact. I think they're certainly complementary to each other. But like, in terms of gaming, I think it's token bound accounts are really cool in the case of, making it easier for certain games to, equip like certain equipment or have like in-game currencies as part of the NFT. And then also for just in terms of distributing assets, like rather than having to take a snapshot at a certain time, you can just like have a list of whoever holds these NFTs and then just airdrop directly into the NFTs rather than the address that is holding the NFT. So yeah, token bound accounts, definitely cool.
Oh, that's awesome. You know what we should do at ETH events is we should just have like EIP numbers and ERC number trivia, and just like have a bunch of contestants who knows all these off the top of their heads. There's a lot of numbers to keep track of. Thanks, Austin, for answering that.
Yeah.
Yeah, that's true. That's a good idea. The trivia. Awesome. Well, I think that was the last question. So yeah, thank you very much, Dan and Austin. It was awesome to have you here today in the episode number 2. And yeah, we are going to have more the next week. We are going to have the episode number 3, and then next week, after that week again, the episode number 4, and then 5. So yeah, hope to see you all there, and thank you everyone who joined us today.
Okay, we're out of time. Yeah, I also had some slides for 6900, so we'll have to talk about that in the next episode. Sorry, I wasn't keeping track of the time here. But yeah.
Oh, as you prefer. Like if I'm okay if you want to keep today, or if you want to.
Let's go through them real quick. Yeah, let's go through them real quick.
Sure.
So that way we don't have to like pull them back in the next episode. So if you're still here and you want to see ERC 6900, I apologize. I'll keep track of. I'll put it on a watch next time. Let's jump on into it. So I just want to talk about ERC 6900 because I did promise I would talk about this in here. We talked about this idea that account abstraction unlocks new user experiences, but it also raises a number of questions, some of which you guys have already asked. But largely, I like to think about like. Honestly, I don't think there's enough conversations going on today about what makes the best Web3 user experiences, because I think there's a lot of different trade-offs, and I think it's really difficult. I mean, at the end of the day, the user applications that put out the best user experiences are going to get the users, right? I mean, Probably. But so we'll end up seeing the best user experience eventually. But I think it's interesting to talk about some of these trade-offs because, especially as a user of the ecosystem, I have a lot of preferences, and I'd love to see those reflected in some of the new Web3 user experiences that we have today. So Web3 user experience from account abstraction, there's a lot of things to think about, right? It's like I talk about account abstraction as being flexibility at the account layer because it opens up a lot of new questions. You could do as a developer what you want to do here. So like questions like, do all users want to hold a key? I mean, that's a big question, right? Like, I don't think my parents would want to have to keep track of an EOA and like store it away in a little hardware wallet in a box somewhere and put a copy of it in a bank or friend's house or something like that. Like I don't think they want to do that. There's a question there like of, do all users want to hold a key? If they do, what kind of key? Maybe they don't even realize they're holding the key, right? If it's a pass key on your phone, right, that's kind of good user experience where people have been using pass keys where they may not even realize what exactly is happening there. So they may want to hold a key. Maybe it's a different type of key, or maybe they don't want to hold the key at all, right? So you may want to have some sort of other custodial model. So where is that key held? Is it held in a browser wallet? Is it held in a mobile wallet? Is it a pass key on your phone? Do they want to have multiple keys for different purposes to be able to do things depending on what like assets they're interacting with inside of their account? So you could have a smart contract account that holds gaming assets. You could have a smart contract account that holds information that's important to your social account on something like a Farcaster. You could also have something that holds on to, let's say, your assets that you're interacting with a DeFi protocol. All those different things are going to require different security concerns. So you may want to have multiple keys. You may want to have like a session key for gaming items where you want to be able to just be able to interact with the game and make on-chain actions quickly. And you just trust the game to, when you press a button, it's going to do what it's supposed to do, right? In which case you want to have a session key that maybe expires after some period. You may want to have some sort of custom recovery logic, right? So if you have an account that doesn't matter much to you, maybe you don't care if there's recovery logic today, but maybe tomorrow you decide like, oh shoot, there's a lot of value in this account. I started playing a Web3 video game that all of a sudden now it's like really important to me. I really care about that one item that I got that one time. Now I want to have some kind of custom recovery logic. I want to be able to have a second key that acts as my like security key that I keep in cold storage, and it only comes out so often so that I can actually move some assets around and say, these are the assets I want to be able to interact with. Or I want social recovery where I can actually have, somebody else who keeps one of my keys or helps me keep one of my keys so I can recover from them. And then there's also a lot of questions about like which smart contract should an account respond to? Like, what about future smart contracts that are out there, right? There's a lot of things that could be baked in here. And this is where like there's no one size fits all when it comes to an account, right? Users may want many different things depending on the user experience. So like I put some examples here. So you could have a Web3 game, a social app, a payments app, a DeFi app. All of these things have different trade-offs, right? And I just put down some of like the preferences that I think I might want in these different experiences, but you could definitely disagree with me here, right? Like with a Web3 game, maybe you want frictionless onboarding because in a game, you don't want to just you don't want to come into a game and have to like set up a social recovery account. You don't want to have to like call your best friend and be like, hey, I'm just trying this game out. Can you keep a key for me? Like that's really silly. You just want to get in there and see if it's fun, right? So you want frictionless onboarding. You want that paymaster who's going to pay for your gas. You want to introduce accounts slowly so that if somebody does get to this point where they actually care about their account, maybe they can transition it over to a more secure model at that point, right? Maybe you want to top up the account for on-chain actions. Maybe you pay for some of their on-chain actions, but maybe you have to eventually let the user pay for those on-chain actions, depending on your business model, right? Some business models may be able to support always paying for the user's gas at the end of the day and just consider it part of their costs for running that business, right? So a social app can make it so that you always are paid for in the social app because they figured out a different business model. Or a payments app may decide the user wants to pay for their fees in a stable coin that's not the native currency of that chain. They can do so with a paymaster. In a DeFi app, you may want to just have a really secure account. So we want to be able to have a standard, an account that fits all of these use cases. And that's really where ERC 6900 comes in. We're hoping to see a lot of a lot of creativity in this and a lot of innovation in the modular smart contracts ecosystem. So ERC 6900 is one of these standards. So this particular standard, the modular smart contract account, has a high focus on security. So we were talking about security earlier, right? When you allow users to install arbitrary bits of code against smart contract accounts that they care about, you have to think about security first, right? You have to be thinking about like, okay, how are those plugins audited? What do those plugins actually control against the account? What is that security model? Like, you have to think about auditors making sure that there's like no bugs in these systems, right? You have to be really conscious of all those things. That's ERC 6900 is built with that kind of idea first. Even the idea of having install time permissions, which is inspired by Android, where each plugin has its own plugin manifest, where when you go to install a plugin, your modular smart contract account actually reads from manifest and sees all the permissions that a plugin wants to be able to use, what kind of other plugins it wants to interact with, whether it can spend native tokens. Those types of things are all baked into the manifest. So a modular smart contract account can install one plugin. You see in this image here that Alice has installed 2 plugins, Bob has installed 2 plugins. They both refer to the same plugins here, right? And each one of these plugins has their own set of validation rules, execution rules, and hooks, some of which you can optionally also put in here. So if we're talking about installation for something that like really simplifies this, you can think of something like this, where you have a modular smart contract account on the left-hand side, you have your Pudgy Penguin, you have a NFT that is like a ticket to an event, you have some Ether in there. And when you want to install a plugin, what you do is you talk to a plugin, you read the manifest, the modular smart contract account says, okay, this plugin wants to be able to execute subscriptions, right? It wants to be able to allow this user to create subscriptions on chain where they pay a monthly fee to something, right? That could be a new business model that's tough to do on chain today, where you set up a subscription that's paying monthly into some other smart contract account. So this plugin will handle the execution of this method in the future, where now when the call comes into the modular smart contract account from a user operation specifying the setup subscription method, it's going to go to that plugin, and the plugin has those permissions to be able to do what it needs to do that were set up at install time. So there's 2 implementations of ERC 6900 that are production ready, coming out very, very soon, which are being produced by Circle and Alchemy. As any good standard, there are multiple implementations here, and there is going to be plugins that can interact with both. And then, so this adds to the system that we were talking about before. I just wanted to kind of take this back to what we were talking about before, where we had that entry point that had each one of these user operations. It does complicate this picture, right? Definitely, where we have a plugin that you could see on the one when you go to the entry point, and for each user operation, it's going to go to the account, which validates, and then it's going to go to the plugin, which validates. And then on step 3, you can see we're going to the account, and then in the account, it's going to call out to the plugin to do some pre-hooks, to execute, to do some post-hooks. The execute is actually going to do the state changes, right? So if we had that set up, subscription method might actually call out to a smart contract to do something. This is definitely a very complicated picture, but at the end of the day, what it really affords us is this ability to be able to create an open ecosystem of plugins, which if you're a Solidity developer out there, or if you're an aspiring Solidity developer, this is definitely something that you could be looking into today, is building a plugin for users that are going to want to install functionality into their smart contracts. It's not an easy thing to do. We'll be releasing resources soon for how to build a plugin. And of course, these things need to be well audited and adhere to the standard. But we're hoping to see like a proliferation of many innovative plugins out there in the ecosystem, so you can install them as a user and uninstall them. And be able to do something where you could build your own account, right? Where you could do things like this particular item is in cold storage and requires social recovery because I don't want to ever move my Pudgy Penguin. Maybe I have like a pass key so that I could use some USDC and a concert ticket if I want to be able to exchange those things. And then I have some things that like respond to token contracts like ERC 721 receive, be able to like configure your plugins, right? You can imagine what this experience could be for a user. And there's going to be a lot of different experiences for how users interact with their accounts. That's another really open area for developers to innovate on. So if you're a developer yourself, building a plugin or thinking about what that account interface looks like is a really exciting new field of development here. So it's an exciting area to be in for devs in Web3. We're going to be getting into workshops in episodes 4 and 5. The next episode, we're going to be talking to a use case, a team that is developing today in the ecosystem, and then we'll be getting into workshops. So there's a lot of really cool stuff coming up in the future workshops. For Solidity developers, you can get involved today, contribute to the standard, or build a plugin. You can go to the GitHub for ERC 6900 and see all the resources there. There's a community call that runs weekly. You can also go on Twitter to ERC 6900 to see everything that comes out. That's going to give you all the latest news on this particular standard. Alchemy is also producing something called the Account Kit. You have an SDK where you can actually interact with these plugins, with these modular smart contract accounts. And V3 is coming soon. That is alpha. So for those of you still here in the extra time, you got some alpha there. The Account Kit is coming very, very soon. So you can be ready to actually be able to interact with these plugins. And we have some tools to make it really easy for you to be able to interact with those plugins. And for Web3 developers out there that, maybe you don't do as much smart contract development, but you focus more on the application side, I'd love you to think about some of these questions, like what should an account look like? What kind of developer tooling is needed, right? Like for every plugin that's out there, we're going to need some specific tooling that interacts with that plugin, right? What kind of new user experiences can we build? So definitely check out Alchemy University. We're going to be putting out more resources there, and we have a vibrant community of people thinking about these things. So yeah, that's everything. Hopefully got through that in relatively decent time. Sorry for going over for everyone out there. Yeah, thanks everybody for sticking around.
No, that's awesome, Dan. Thank you very much. It was a great presentation, to be honest, and Austin, thank you too. And yeah, I just shared the link to Dan's presentation. You can find it in the comments. But yeah, there are some questions left, but I took a picture of them, and we can answer them in the next presentation in the next week.
Cool.
What do you think?
Yeah, that sounds good to me. Yeah, I don't want to keep you guys any longer. Sorry about that.
No, it's great. It's great.
Sweet.
Awesome. Amazing.
Well, thanks everyone. Thanks for hosting, Anna.
Yeah.
Of course. Thank you for coming. It was awesome. You're awesome, to be honest.
Thanks, everyone.
Bye. Thank you. See you in the next one.
Bye.